Hello and welcome to the January session of Mytech U. Today we're going to be focused on high-density wireless and some education around some common problems that are encountered when deploying wireless networks. The problem is a lot of times people think that wireless is just something you go down to buy at Best Buy and you put in your home and gosh, it just works. But when you get into a corporate environment where you've got hundreds, if not thousands, of devices and potentially other offices with other wireless signals that might be conflicting or causing problems, that's when this education is really going to be focused on understanding why those things happen, why those problems happen, what's the best practices of deploying wireless. And Eric Thrall from Xirrus has one of the best solutions on the market, if not the best solution on the market for high-density wireless. And Eric's going to be guiding us through this. But a couple housekeeping things. There is a question tab or question part of the GoToMeeting control panel at the bottom of your screen or on the side of your screen. Throughout this presentation, please, if you have any questions, please interject. There's going to be about 30 minutes of presentation with up to a 15-minute Q&A at the end. However, if there's something question that pops up and it's pertinent to the presentation and I need to interject, I will. So please flag your questions or ask them through the control panel, and I will be sure to ask those of Eric. And if we don't have enough time to answer all the questions, we'll be following up personally with everyone and making sure that they have their questions answered. So with that said, thank you everyone for joining the January webinar. And Eric, I'll turn things over to you.
Great. Well, thanks, Nate. This is Eric Thrall. I am the regional manager for Xirrus. We are a high-performance wireless solution. I'm going to try to make this less about Xirrus and more about what we've seen out in the industry and out within our customers and other prospects that we're working with and some of the problems that they've kind of encountered. It's not so much really about problems that they encountered, it's just things that you really need to be aware of, and also some best practices out there. So without further ado, I'm just going to kind of go into a little bit of the agenda. So again, we're going to just talk briefly about some of the market dynamics, some Wi-Fi basics. I'm hoping everybody on the line has some of this basic information, so I am going to breeze through that fairly fast. Kind of the traditional Wi-Fi approach. Most solutions out there, 2 radio access points, one that supports the 2.4, one that supports the 5 gig with a centralized controller. That's pretty much been the standard approach since wireless has really been introduced. And just going to talk a little bit about those approaches. Capacity planning is what I'm really going to try to stick to and talk a little bit about that. Really, when you talk about capacity, you need to start thinking of wireless in the same sense as you do with the wired infrastructure and how you plan for capacity. So we'll touch a little bit about that. I am going to talk a little bit about the future of protocols that are coming down the pipe, and there are a couple that should be introduced in 2012. At least that's what the IEEE has presented and is rolling out here sometime this year. And there's a lot of analysts and a lot of expectations that will be coming with this protocol, and so I'll talk a little bit about that. Talk a little bit about some signal strength and what that really means versus a coverage type network. And then again, I'm only going to talk maybe a couple slides about Xirrus and see if there's any time for some questions and answers. So without further ado, really when we start talking about 802.11 and soon 802.11 AC, we're really talking about the performance and the throughput of wireless. And up until 802.11n, we really were kind of, everybody's expectations of wireless was, well, if I get a signal and I get some internet connection, great. But kind of those times have changed with the evolution of 802.11n, and especially will change when 802.11 AC become prevalent and become an actual protocol where device manufacturers will start speccing their solutions, the iPads, the laptops, whatever it may be, with this new protocol and what that means. But if you kind of look at the parallels between Ethernet and wireless, you'll see that it's kind of, we're just about 10 years behind from a networking perspective. So just some statistics and analysts on the side. Again, tablet sales have officially overtaken the market. The Best Buys out there have reported that the tablet sales have basically surpassed any type of laptop sales. I don't know if there's anybody out there that's really buying any tower or base station type computing devices, and we're just seeing this as not stopping anytime soon. And obviously with these new solutions, we're starting to see that these devices don't even have an Ethernet switch port. So becoming very knowledgeable about the wireless and what it means and how to plan for this explosion of devices is really should be forthcoming over anything else. Any solution out there should be able to provide coverage, but what you really got to start thinking about in your network is the wireless network in the very near future will become your primary network. And whether you like it or not, it's a fact that every device out there is wireless to some extent. And we're just starting to see that these devices, whether it's you're allowing people from home to bring in their own devices, the BYOD, or if there's an initiative within a company to start presenting or offering tablets, laptops, whatever. So in the near future, you are going to see that the wireless network is going to become your primary network. It's inevitable because of the sheer number of the devices and the cost of these devices coming down, and everybody already being very accustomed to working with those devices. So again, just some kind of timelines here. You know, 802.11n is kind of the standard of today. It's been around now for a few years. There are some stipulations around those requirements. Most people recognize 802.11n with providing 300 megabits of throughput. And correct, that is a correct statement, but to make that 300 megabits of throughput, you do have to bond some channels together within the actual spectrum to get that 300 megabits. And again, remember that 300 megabits is throughput. That's both upstream and downstream. So at any one point, you're really looking at about 150 megs of throughput in one direction. Now, that 150 is also a number that you should take into consideration, because you'll get that type of speeds if you're standing right next to the access point. Any type of distance away, any type of a wall in the way, you're going to see that number typically cut in about half when it comes to a throughput perspective. And we've done some extensive research with pretty much every solution out there on the market to take a look at those actual throughput numbers. So again, some things that you need to take a look at when you're kind of designing a network for capacity to support all these devices that will be coming into your network. In the near future,
Eric, if I may interject on that point, I guess. So when people look at, so from an end user perspective, when they're sitting and they've got their laptop or they've got their smartphone or their tablet, and they see those bars on their on the screen, seeing as far as how strong of a signal. So the actual throughput they get, it's not just about the signal, but it actually then dictates the throughput that they get.
Yeah, absolutely. So if you have 10 people in a conference room and you all have 4 bars, and your bars on the bottom are telling you give a 300 meg connection, you're not getting a 300 meg throughput connection. Obviously, wireless is a shared medium, so you're going to be sharing whatever bandwidth is available on that radio that you're associating to. And again, your devices dictate which access point or which radio in that access point it's going to associate to. So I kind of use the word radio and access point interchangeably. Most access points, again, are 2 radio access points, one supporting the 2.4, one that's supporting the 5 gigahertz. So your signal strength is correlated. There's a direct connection between your signal strength and the amount of users to the actual amount of bandwidth that you're going to be experiencing on that wireless network. So,
great, thank you.
Yep, and then again, in 2012, it is expected to release these next generation of protocols, 802.11ac and 802.11ad. 802.11ac plays in the 5 gigahertz spectrum, and this is really a protocol that analysts are all expecting to really be the breakout protocol for wireless. You're going to see every wireless manufacturer or every wireless device implementing 802.11ac once after it comes out and gets into a draft format. As soon as the IEEE releases that and allows it to go into a draft format, chip makers can start speccing their devices with this new protocol. And again, 802.11ac is going to provide a gig of bandwidth or of throughput. That's going to really revolutionize the wireless industry of what traditionally what people have thought of wireless. And the analysts are expecting this to really take off, and it's going to be the next kind of breakout thing that organizations are going to be interested in, looking at. If I can provide a wireless speeds as fast as I am connected to a desktop, why wouldn't I want to go with wireless? It's much easier. I can have many more users. The traditional approach of having a switch port connected to an individual device is going to be something of the past. So that protocol is expected to be introduced into the market as in a draft format sometime here in 2012. So, and again, that 802.11ac protocol only plays in the 5 gigahertz spectrum. So we talk a lot about the 2.4 and the 5 gigahertz spectrum, and I'm going to talk a little bit more about the limitations of those two spectrums. So here's exactly some of the bands and channels. So in the 2.4, everybody, this should be a little bit of review, that if you have some basic understanding of wireless, 2.4 spectrum, you have 3 non-overlapping channels. Basically those channels that are everybody sets up within their networks is channels 1, 6, and 11. All 3 of those channels are non-overlapping, so you don't create any interference amongst other access points that you have within your network. And so you really don't bond, or too many organizations bond the 2.4 channels together, because now you've just eliminated, or have you've basically eliminated not 3 channels, you've taken 2 of them out of the equation. So if you have those spread out throughout the entire facility, most organizations just have one radio or one channel in the 2.4 set on their access points.
Well,
the other spectrum.
Second, let me interject here, because what I don't want to do is I don't want to make some assumptions of basic understanding of wireless. So you know, I know we talked about 3 non-overlapping channels, but that assumes people understand that they know the different channels that even exist, or how some of that even work. Can you take a step back on some of this and just make sure that it kind of lays some foundation of, you know, the different channels that exist, and what this means, or how the channels communicate, and why that then kind of goes into what you're describing?
Yeah. I mean, the 2.4 network. I mean, so when we talk about 2.4, we're talking about 802.11. B, G, and N. All right, B, 802.11b provides 11 megs of throughput. 802.11g provides 54 megs. 802.11n theoretically supports 300 megs of throughput if you bond 2 of those channels together. In most organizations, in most implementations, you do not bond those 2 together, so you really have one channel that you're utilizing, which is 150 megs of throughput, or of data rate. So those are just the 3 channels that you can use in the 2.4, period. There's nothing magic about it. That's what everybody utilizes. And the 2.4 signal does travel further than the 5 gigahertz spectrum. Now, the 5 gigahertz spectrum, when we're talking about that, we're talking about 802.11a and n. Again, 802.11a came out about the same time as 802.11g, and that provides 54 megs of throughput. But the caveat to the 5 gigahertz is that most networks, many networks I should say, when they set up their networks, they actually do bond multiple channels together on that 5 gigahertz, because you have 24, really 21, not excluding the first 3 that are in the 2.4. But you exclude, and you can bond those together to actually get more throughput on a per radio basis from devices associating to the access points. So I don't know if that exactly answered your question, but that's kind of just a quick background of kind of the wireless and the different channels that are out there. You know, a traditional Wi-Fi solution, again, most of them are all typically the same, and they all have their secret sauce. They all work, so I'm not here to bash anybody. They all work. Most of them all have one 2.4 radio, and one has one 5 gigahertz, and they all have a centralized controller. The thing that I like to think about with this approach is this has been the traditional approach since Wi-Fi has ever been introduced. You have thin clients out there. They're typically don't have much intelligence at the edge of the network, and you have the intelligence sitting back in a centralized controller. And so you're just seeing that this is the traditional approach. Now, most manufacturers of wireless out there are starting to push more and more intelligence to their actual access points because that makes sense. That's the edge of the network. So, a lot of these solutions, if the controller goes down, yes, the access points will still function in some form or fashion, and they'll allow users to connect up. But you're just starting to see that this transition of having a centralized controller versus having the intelligence at the edge of the networks seems to be gravitating towards more of the manufacturers pushing more intelligence to the edge of the network in their access points and not having all the intelligence and everything back in the centralized controller. Again, when you think about this and you start applying security encryption onto each packet that is being sent out over the wireless network, many of the controllers out there, when you start getting into a dense environment with a lot of devices, the controllers can get oversubscribed or they just get worked very, very hard. Again, all these solutions work. There's nothing wrong with them. It's just that it's been the traditional approach since wireless has been out there. So again, I'm going to kind of skip over this. Again, it just kind of goes to a little bit of the history and evolution. Single radio access points. Then we started pushing a little bit more intelligence into the second generation, third generation. We're starting to see more antennas in the devices. So we're doing like a 3x3 MIMO technology, so we can get to some higher bandwidth and data transmission from devices to access points. And when we talk about coverage and capacity and really designing for the future, some things that we like to make sure that people understand is, a predictive estimate on a site survey is exactly that. If you come in, you start throwing up access points, and you really don't know what your airwaves look like, it's difficult. It's difficult to understand exactly what your environment holds. For instance, you put an access point near a kitchen and they're utilizing the microwave ovens a lot, you can throw out a lot of interference. As well as with the 2.4 signal, in many cases, the signal strength from 2.4 travels very far. So in this scenario where I have all these access points throughout, if I had this access point with one of the channels set to channel 1, which is a 2.4 channel, and I had another channel set to maybe channel 44 in the 5 gigahertz, I'm pretty sure that you would see that channel 1 all the way over to this part of the building. So what ends up happening is you actually have to start turning off the 2.4 radios in the access points, or else you simply start creating co-channel interference. So it is a best practice to have a site survey done so you can plan your deployment and really try to set up a network that's clean. Clean air, so you don't have a lot of interference. It will make your wireless network much better. So.
Well, Eric, on that point too, I think in our previous discussions, it's not just about whether or not their own internal wireless, but if you're in a building that's got multiple tenants, you could also be seeing interference from other tenants in the same building. Is that right?
Absolutely. Absolutely. In fact, we find that very often that when you do go into a multi-tenant facility and we turn on a Wi-Fi inspector, which is a tool that a little gadget that you can download for free off our website. You don't even need to put in your contact information. You'll be able to see all the wireless devices and their SSIDs and which manufacturer it is within your environment. So we do that test a lot in front of prospects and customers just to say, well, let's just take a look at your airwaves right now and see what's all out there. Downtown Chicago, we turn this on, we'll see hundreds of access points throughout, a complex, a high-rise, or wherever. So it's something that you definitely need to be aware of, and you can actually create co-channel interference that will actually make your wireless actually unusable if you have too many channels 1 present, too many channels 6, too many any channels. If you had too many channels 44 in the 5 gigahertz, your devices are just basically not understanding where they're supposed to be sending the signal. If you relate it to listening to multiple radio stations all at the same time and trying to understand the songs, that's kind of what you're looking at.
Yeah. So to correlate to what you're saying is that, I mean, realistically, and that's the great thing about wireless is that people are using it more and more, and the devices are being used more and more. But but that's also the same reason why we have problems with deploying wireless, is because everyone's using it, and because there's only a certain number of channels that can be used. Like you said, it's like trying to listen to all different radio stations at the same time. That if you don't really plan this, or at least before you deploy something, seek out that might exist, you could just experience a lot of problems with your wireless and maybe not be deploying the right solution.
Absolutely, absolutely. So another kind of key number that we like to kind of clue in on is just the number of devices per radio. You know, anywhere from 15 to 25, 20, 25 users per radio is going to provide a good end user experience typically, all right? That's not a Xirrus thing. That is a standard industry concept or out there. So the access points out there have the ability to associate many more devices than this. In fact, some access points can associate 250 devices to one access point. But what I would caveat on that is see how many, if you had 250 devices associated to an access point, you would basically be going, you'd be crawling at a dial-up speed with your internet or with your, you know, with your throughput. And really it makes wireless not a very attractive network when it's so slow, all those other characteristics that you have to deal with. So
Eric, could you distinguish between, you used a couple different words. I want to make sure that everyone understands the differentiation. You mentioned 15 to 20 devices per radio, and then you started talking about access points. Now, some access points have multiple radios, so can you distinguish that and make sure that we're all on the same page about what that might mean as far as the number of devices?
Yeah, so a typical access point, again, have two radios in there, 2.4 and 5 gig, and your devices dictate which access point or which radio within that access point they want to associate to. So they're out there, they're sending out their beacon requests, and they're saying, who is the loudest? You're the loudest, I want to associate to you. So they are actually sending out their signal, and the access point says, okay, I hear you, you want me, I'll associate you to me. So I'll allow you onto the network. Now, what people also forget about is that if they have their cell phones in their pocket or any other smart device, and they have that Wi-Fi turned on, those devices are also asking to be associated to that access point too as well. So in many cases when, for instance, we do a lot in the education vertical, it is our biggest, strongest vertical that we go into, and mainly because that's where all the wireless or high-density wireless is really being brought into the market. And we like to tell customers that, you know, when you are deploying this, and if you have 30 devices in a classroom, are you allowing students to bring in their smartphones? Because if you are, you have to start thinking about not 30 devices in that classroom, but 60 devices in that classroom, all wanting to associate to the network, when whatever that network is at that point. And if that strongest signal is only a 2.4 signal, then that's the network that they're all going to try to associate to, slowing down the use of everybody else. So again, I try not to confuse too many people with the radios and access points. Typically, again, there's 2 radios per access point in most solutions out there. Xirrus has a different approach. We can kind of touch base with that very briefly at the very end. I actually had a
Yeah, I just want to make sure that when you were defining radios, that we understand that there can be multiple radios in an access point, and that can be different than just considering 15 to 20 per access point instead of per radio. Yeah. So thank you for clarifying.
Yep, and also, so on that last previous slide, there was something that said view Gartner iPad report. If I have time at the end, anybody's interested, there's a report that was just released in October, and actually I can probably do it real quick because it is kind of nice to just see. And this report basically just comes out and it is indicated that even the networks that are being introduced out there, that are being deployed today from a lot of manufacturers and resellers, they're really not taking into consideration these bring your own devices in, the iPads, the tablets that are coming into networks, whether you like it or not. And what they're basically indicating is that you're going to need a lot more access points to support all these devices. And what they're also indicating, and through our studies as well, is we're finding that the 5 gigahertz spectrum is what you really want to start utilizing in high-density environments. We've known this for many years. This is what we use to support some of the largest events in the world. You can't support real large events relying on the 2.4 network. And we're really seeing the 2.4 network kind of from a futures perspective with no real advancements coming in that 2.4 spectrum. Again, 2.4 spectrum works today. There's a lot of users on it. There's a lot of devices that associate to it, so it's not going away. But you're just starting to see more and more devices gravitating towards that 5 gig environment. For instance, the iPad 1, when it first came out, gravitated to the 2.4 network. iPad 2 came out. If you had two radios sitting side by side providing that iPad 2 with the exact same signal, it would gravitate to the 5 gigahertz spectrum. And that's kind of what this analyst is indicating. And with this analyst, they're also indicating that the tablet devices don't have as strong of an antenna in their actual devices. So what was good for a laptop deployment with providing a strong signal is not necessarily the same type of performance that you're going to get from a tablet devices, because they actually require a stronger signal to function at their optimal levels. I thought there was a couple of things that I had in here. Oh, and then again, so this kind of goes back to the network capacity planning. Gardner kind of recommends having about 6 megabits of throughput on a per wireless device. So on that note, if I go back, it kind of correlates to what we've been saying to our prospects and customers for many, many years, is that if you were going to deploy a wireless network for, let's just say, 150 devices, and if you compared that to what you were going to do in a wired design, then you would obviously put in some switches, and you'd have some 20% growth in there in case you added a few additional devices. Well, with wireless, the traditional approach was, well, we'll just put one access point, it'll cover all that. If you do the math on this, and this is your theoretical throughput, so the 450 is taking into consideration one radio at 150 meg and bonding two of the 5 gig radios together to get 300 megs. So there's 450 megs of throughput theoretically on a per device basis. So you're getting about 3 megs on a per device basis, right? Now, in actuality, we've done a lot of studies on this, and you're not getting that type of throughput. You're not getting 150 megs of throughput unless you're standing directly underneath the access point or right at it. If that access point is through a wall, realistically, you're probably getting about 20 megs of throughput, or if you bond some channels together, you might get getting 40 from a traditional omnidirectional access point. Again, omnidirectional access point is what most of the solutions out there utilize. The signal is broadcast off in like a light bulb fashion in a 360-degree pattern. We've kind of done a different approach where we use high-gain directional antennas, and they actually can provide a lot stronger throughput and signal strength from the distances as well, but I'll go into that a little bit later. So if you actually look at the actual throughput, your actual, from a device perspective, on a per device basis, you're not even up to a meg per device. And this isn't something that, it's just something that we've seen in so many networks. We come out, whomever's bidding or is implementing that project is really taking into consideration a coverage type network. Hey, I've got 3 bars in this room. I'm good. What happens when you throw 15 devices on that network with 3 bars in it? The network starts to drag, and you really haven't done yourself justice by really starting to do more of a capacity planning for the amount of devices that you're going to have in your network. So let me go to my other view. Sorry about that. So how does most traditional approaches attack this? Well, they start adding access points. That's the traditional approach. Hey, I need capacity. Well, I better add some access points. The problem with adding access points in most traditional solutions is that, again, one radio is a 2.4 and the other one's a 5 gig. That's fixed. That's what they have. So you actually have to start disabling that 2.4 radio in that access point, or else you'll start creating co-channel interference within the network. If I have too many channels 1 all present, I basically make that channel 1 not very usable because my devices I got 2 radio stations, for analogy, speaking at the same time, and I'm trying to understand it as a device sitting out here going, who am I listening to? So when we do very large events, we stick to the 5 gigahertz spectrum, and so does everybody else. They simply have to turn off, in most traditional approaches, have to turn off that 2.4 radio on on every other access point or whatever, so that they don't create that co-channel interference. So these were just some statistics. I'm not picking on Aruba at all means. They're a very popular solution. They've got a great product. This is just some throughput testing that we've done. So if you kind of look at a Xirrus, one of our 8 radio devices versus an Aruba 2 radio array with 3x3 MIMO technology, both of ours have that, you'll see that once you start getting a little bit of a distance away, and again, we utilize high-gain directional antennas, so we can provide a stronger signal. There's no question about that in the industry. A high-gain directional antenna does provide a stronger signal than an omnidirectional antenna. But what you really start seeing is that from a distance, and this is kind of representing with that green bar, at 100 feet distance, the signal drops off dramatically, and that throughput drops off dramatically as well. So that's where, if you're designing it properly, start thinking about capacity and density as opposed to coverage. Any solution out there that you go with should provide coverage. Coverage is 5 years ago's wireless network. Density is the future of wireless. So again, maybe my quick little scenario. One of my arrays typically can replace anywhere from 3 to 5 access points. In some scenarios, it's not that many. Sometimes it's only 2, depending on the environment. And in many cases, I've done site surveys where we've replaced 6 or 7 access points with one of our arrays, simply because we utilize high-gain directional antennas, and I push my RF typically twice as far as an omnidirectional access point. So again, kind of from a density approach, this is what most thin access points would do. They simply add a lot of access points. For ours, we can typically do deployments with a lot less of our devices. And again, the intelligence of our device is at the actual access point versus most solutions that are at a centralized controller.
Well, Eric, so could you take a moment? You know, one of the things that makes you're showing it here a little bit, but could you talk about the fact that you have directional antennas? Where did that concept come from? And so as far as, I mean, because people don't know, like, well, why would I choose to use one versus the other, and why did Xirrus choose to use the directional based on the proven technology that exists today?
Yeah, absolutely. So one of the things that our founder did, and our founder, Dirk Gates, actually founded a company in the early 90s called Xirrus, which was one of the very first Ethernet adapter for laptops, because when the laptops were introduced, they didn't have an Ethernet adapter. So he started that company and sold it to Intel. But what he found is that he basically looked at what the cellular industry did. The cellular industry used to have single radios, towers. They'd have a radio up on a tower. It broadcast off in a 360-degree pattern, and it worked just fine until everybody started wanting a smartphone and a cell phone. And then what they did is they basically converted all those single radio towers to have multiple high-gain directional antennas up on the tops of these towers. So if you look at tops of buildings, water towers are a big one as well, or they're out in cornfields or wherever. Those long rectangular bars are high-gain directional antennas, and they typically have multiple of those all in, facing one direction, so that there's multiple lanes of traffic for any devices to see multiple. They have multiple lanes of access to the network. So if there's an emergency, for instance, and everybody jumps on, there's multiple lanes for users to get onto the network. So he looked at that industry and he copied it, and he said, that makes a lot of sense. Why don't we do that? So we hired some of the best RF engineers. We designed the antennas. Everything is produced in the United States. We are a wireless manufacturer. We do nothing but wireless, and it is our forte. It is our sweet spot, and it's what we, what our expertise is. So that's kind of the tradition of our array. The beauty of our latest array, the XR array, is that what you're seeing here is the insides of an array. And what we've designed here is we've designed the very first modular wireless device. So these are all these cards. These are radio modules in our array is what we call our device, because it has a lot more. It's a lot more than just an access point. But each one of those are removable. And what that means is that our founder basically created and put a 4-core Kelvin processor in each array, which provided about 10 times the processing power that is needed for today's standards, for today's 802.11n standards. So each one of our radios can support, again, from an associations perspective, about 200 users. In fact, I think we bumped that up to the maximum, which is 250. Again, that's associations. We don't really like to talk about that. That's marketing. Realistically, again, if we go back to the 15 to 25 users per radio for a good wireless network, each one of our radios can be removable, and he's actually provided a processor there so that when 802.11 AC becomes the next standard, you'll simply purchase a radio module that will support 802.11 AC, slide it in, do a firmware upgrade to the array, and you'll be able to support 802.11 AC. So I can sit here today and tell you that any array that goes into a network will be there for a lot longer than any other solutions out there if they want to upgrade to those latest protocols that are going to be on the market by the end of this year. So pretty cool stuff, definitely cool stuff. This is an 8 chassis array. I think my next one, it's the same chassis. It's an 8 radio with 4 open slots. So for those individuals that say, hey, you know what, we don't have all this wireless in our network, great. Purchase a 4 radio with an 8 slot, and if you do start going to that all wireless type environment, or your wireless does start surpassing your wired environment, you have 4 open slots. These open slots could be utilized with 802.11 AC or AD radio modules in them, so you can have a mixed environment in your actual arrays when that protocol becomes a standard. In the very near future, we will have a 4-slot array as well, so you'll have up to 4 radio modules that you can put in that. And then our founder kicked and screamed, and we've been kicking and screaming, I should say, to our founder, and he is officially going to introduce a 2-radio access point as well. He really didn't want to, and I don't blame him. That's what everybody else is doing, and with all the devices that are coming into the network. But realistically, he understands that there are areas within any network where you don't need a high-density solution, and putting in a little 2-radio access point to cover 5-10 users is going to be just fine. So we'll have that in the market here by the end of February. We'll have introduced a couple additional arrays. So really, from a scalability perspective, we'll have a complete portfolio of whether or not you want to go with a low density, or if you want to propose a solution that's going to be able to scale to whatever the future holds for wireless within your network, we'll have that as well. So we'll have kind of the whole portfolio, and that's been a hole in our portfolio out there for a while now. So we're all looking forward to that.
Great. So one of the things on the wireless front, as far as planning capacity, I mean, everyone that I keep talking to is talking about tablets and smartphones, iPhones and iPads and things like that in particular. What are some of the things that people should be looking out for or thinking about? Because I remember you telling me a story about how iPads couldn't even talk to certain radios or something at one point. So can you talk a little bit about that, as far as making sure that you can build networks that are compatible for these different devices and some of the experiences you've had?
Yeah. So what we're finding out with a lot of environments is you're mixing protocols. So you have your handhelds today basically connect up to the 2.4 network. That's the capacity that they have from a Wi-Fi perspective. Some of them are coming out with 5 gigahertz chipsets in them, but most of them will support maybe 802.11g in their smartphones. Then your laptops all support 802.11n. If you have any real old devices, scanner guns, stuff like that, they might only support 802.11b. So some of the things that a traditional approach has been is when you start mixing protocols on an access point, it's not so much that you reduce the throughput down to the lowest common denominator, so that if you had 802.11b devices out there talking, that that those 802.11n devices now have to talk at that 11 megs of speeds as well. That's not the case. It's just that those protocols speak so much slower and take so much more time that, again, when you're in a half-plex medium, that when I'm talking, nobody else can talk, you're simply having to wait to transmit those protocols. So some of the things that our founder did within our array is that we can actually set, and maybe if I go back to some previous slides here, what our founder did is we can actually set in the array and have any one of our radios only associate those devices with those protocols. So if I want, I can set, if I know I have an area of my network, like a warehouse facility, and it's scanner guns in there, well, but yet I have my laptops on my, maybe on my forklift, and it's traveling, and it can communicate at 802.11n speeds. What we can do is we can actually designate certain radios within our array to only associate those, whatever protocols those are at. So I can say, if you're a B device, you're only going to associate to this one radio module. If you're 802.11n, I can set you up. Now we don't do that a lot, but there are applications and there are environments that we do that. And it was something that a very large electronics retailer had asked us to see if we could do that, and we basically said, yeah, we can do that because we're pretty much the only solution that has more than 2 radio access points. Though you are starting to see more and more manufacturers coming onto the market with more radio access points. They're starting to introduce them in beta forms and everything else. So it's kind of, in our eyes, a little bit of proof in the pudding that, yeah, the only way to really increase capacity and performance is to increase your radio count within your environment. Now, there's a lot of techniques and there's a lot of secret sauce behind a lot of people's solutions. They've got different applications. They've got terminology, beamforming, and bandwidth steering, and they do a lot of different things within their application from a software perspective. But realistically, it still relates down to from a radio perspective. And the fewer, I use this term a lot, but the fewer the devices per radio, the better the end user experience. And that does hold true if you're, if you're on the network and you're doing something besides general web surfing or emails. That statement is a true statement. Now, if you're just doing general email and web surfing, then yeah, you can have 60 users on a radio. But when you're starting to utilize the network for what you're doing within a work environment, those are kind of some of the things that we're seeing out there in the environment. So, again, just to kind of recap, when you're looking at deploying a network, make sure you're thinking about capacity planning. Make sure that you're thinking about some of the future protocols down the pipe. Are there solutions that are going to start being able to support these new next generation protocols? I'm sure that as soon as that protocol is drafted, they will. But today, from what I understand, there are none. And then just from a simply start doing the math. Start doing the math on the number of devices and the actual bandwidth that you would like your devices to have, as opposed to looking at the bars and saying, well, I have 3 bars, I must be good. Well, if your conference room has 3 bars and you put in 20 users all in the network at the same time, the network will typically start dragging a little bit. And those are some of the things that you definitely need to start considering and looking at. So do we have, maybe we could open up for some questions.
Yeah, I've actually asked the questions that have pretty much come up throughout the session, so digging into those different variables.
Okay.
So I want to say thank you, Eric, and appreciate the summary, because the biggest part is that, the challenge that, we, Mytech, why we wanted Eric to do this presentation today is because wireless is becoming more and more prevalent. Not only the people using wireless devices, meaning deploying wireless networks, but also wireless devices, the tablets, the handhelds, the scanner guns, and all those different variables. And it's creating it's more difficult to deploy a wireless network that actually works and gives you the performance that's similar to what people are used to in a regular wired network. So that was and Eric did a good summary, is understand the devices and the throughput, the kind of traffic. Are you just doing email, or are you also trying to do graphics? Are you doing high bandwidth communication or low bandwidth communication, and making sure you factor that in the equation for the next step so that you can actually do the math, understand the number of radios that you're going to need to support the number of devices at the throughput that you need. That otherwise you're going to make an investment in wireless and it's not going to work for you. And that's what we want to prevent, is making sure that any investment you make in technology, any investment you and wireless included, that it's going to actually meet your requirements, meet or exceed your requirements.
Yeah, and on that note, just recognize that the tablets that are coming out, the radios, the radio chips in those, they're just not as strong as what you've traditionally seen in a laptop. So what works today for a laptop environment, typically if you want that same type of performance on a tablet-type device, through our research with the Apples and RIM is a big customer of ours as well. We've just found that those devices require a stronger signal, and they're all starting to gravitate towards that 5 gigahertz spectrum. So again, a lot of the traditional approaches out there have relied on that 2.4 coverage type network for their wireless, and that's worked fine. But until all these devices, and again, I can show multiple analysts that are all saying, when you're deploying this, you really need to start considering that 5 gigahertz. That is the way of the future. That is where you're going to get the most bang for your buck, the more performance and everything else. So,
well, thank you very much, Eric. I appreciate your time on the webinar today. Thank you, everyone, for attending and watching, whether they watched it currently or the people that will be watching this in the future as we do record these sessions. And if you have any questions, please feel free to contact Mytech, and we can make sure that we are able to answer your wireless questions as they come up. So thank you very much, everyone. We're signing off for today. Have a great day.
Thanks.